Right, so now let's go through each of these. Okay, so add an item, take an item off the list, print, and then make a deep copy, which isn't, since it's just kind of a fun thing we can do at the end. All right, so linked list. All right, let's say we wanted to add an item. Okay, and remember our linked list is going to look as follows, and I'm going to give you the beginnings of it. And what you're going to have is you're going to have class linked list. I'm just going to say LL. Like ladies love cool James. No one gets that reference. It's so dated. And node. Class node? Class node, and it's a private in a class. So I believe that's you'll see the actual text. I believe it's private class node, but I always have to look it up. So I think we can go private class node, and remember a private inner class. So this is just a class defined within a class. A private inner class can be used directly by the outer class. Okay, and then we'll have int data. Okay, right now we're just going to concentrate on ints just to get the fundamentals of linked lists down. But you'll find that doing it for anything is kind of the same deal. And then we will have a reference to the next link, which is node link. Okay? And what's cool about this private inner class is the outer class can use the data and the link directly. So you don't have to have getters and setters or anything for this node. In fact, this is a common way we do the node when we do the private inner class thing. So that's the nice thing about private inner classes. Our node class is done. This is it. And we can directly set the data by saying data equals, and directly set the link by saying link equals, etc. Okay? And then our class linked list is going to have one private variable, and that's going to be node head. Okay, a head reference. And the head reference is going to reference the first node of a linked list. Okay, so head.data is going to be the data of the first node if head's not equal to null. All right, and head.link is going to be the link of the first node. Let's start simple. The first thing we always do with our classes is we have to make a constructor. And what's the point of our constructor? It's to initialize our private variables, okay? In this case, we have a private variable of head. How do we initialize it? Well, we give it an initial data and an initial link, okay? So if we create a linked list, all right, we might have a few different constructors. We might have a constructor where nothing is passed in. And what does that mean? Well, that means that we will set head head referencing null. Okay, or another way to say that is set head equal to null. It references null. Okay, that means it has no memory location in it that it's pointing to. It's not pointing to a valid object. It's null means this object, this reference type, is not referencing anything valid. It's like it's referencing nothing, right? Null means nothing. Okay, cool. We might also have a constructor that takes in a data okay, and it takes in data, okay, and that data will be then we'll make our head. Let's say it takes in the number 5, right? Then head will point to 5, and 5 will point to null. Okay. We could actually make constructors here to be like, if you wanted to be like, well, we're gonna make a node constructor that deals with the idea of setting these things, or we can just set them directly, okay, from linked list. So we're gonna set them directly by saying, you know, data equals whatever, and it'll know that we're talking about this data of the private inner class, okay. I like. We're gonna say head.data equals whatever, right? And head.link equals whatever, okay? And notice that this is equaling null. So when we create a linked list, we can either create it with one item or we can create it with no items, okay? We can grab head pointing to null, which means there's nothing in our list, or we can give it data for one item. In this case, our data is going to be an integer. It's going to be a linked list of integers or a list of integers, and so we can give it a number, okay? And yeah, and so we can get head.data, we can get the data, so we could say head.data, and that'll always be this. In linked list, okay? And we can also say head.link equals null. That's fine too in this case. Head.link equals null. Okay, so head.data equals 5, head.link equals null. Notice the difference between these two situations, okay? So if head is equaling null, that means head is not pointing to anything valid, okay? If head is pointing to a node, and that node link is referencing null, okay, that means head is pointing to a node that's got data in it, but the link of that node is pointing to null, all right? So this is what the first constructor will do. Where nothing is passed in, we'll have this situation, okay? And the second constructor, where we take in a piece of data to start our list off, will be this situation. Okay? So either head's going to be referencing null, which means there's no nodes in our linked list yet, or we're going to have one node in our linked list, okay, and we know it's the last node in our linked list and the first node in our linked list. It's the first node because head is pointing to it, right? And it's the last node because its link is referencing null, okay? So let's take a second and do the two constructors. They're there for you to build up, and then we'll go into. I know we said we would do add, but we have to do constructors first. Obviously, I forgot. All right, so we'll do the constructor. The point of the constructor is to initialize our private variables. We'll do that, which is just one thing, a node, and then I'll see you next video where we'll try to insert into this thing.